Very good afternoon. Sorry. At the outset, I would like to thank the director of the Directorate of State Archaeology and Museums of Government of Maharashtra, Dr. Garge, and all his colleagues for these 2 wonderful days where we've been able to take a deep dive into what's actually happening in the historical monuments of Maharashtra. And I thank you for this the invite to deliver this session, this talk here. I'll keep it as concise as possible. Those of you who know me, I can keep talking, so I'll do my level best to stick to time. So, having listened to all that transpired in the last 2 days, I've actually revisited what I wanted to talk about, and I in fact finalized the title of my talk this morning and rearranged my thoughts as far as the presentation is concerned. So with your permission, the presentation is on role of engineering in taking built heritage conservation in India to the next level. And the work that I'm sharing here is from the years of experience at IIT Madras, but the collaboration and the efforts of multiple co-workers. So it's not something that I would have been able to put together alone. Very quickly, I have organized my presentation in this manner. An introduction, which is common to the whole country, I would believe, Built Heritage Conservation Framework in India. I want to touch upon Sustainable Development Goals very briefly and cultural heritage, because that's the direction that we are, as a planet, we are becoming very cognizant about, again, because it was so in the past. And the question of structural engineering, my domain with respect to cultural heritage. And then I want to look at a few thrust areas, and I have listed 6 thrust areas here, which to me are fundamental in terms of built heritage conservation. So I'll be looking at one example each in each of these, and I really wouldn't have the time to go into the specifics of each of these projects, but just the essence at this stage. And wind up with the way forward for institutions such as the Directorate here in Maharashtra or any other implementing agency, national or at the state level. So let me look at this, and all of you are related to the subject of built heritage conservation, and so I wouldn't have to go too much into this aspect. We know that in a country like in India, we have a very large stock, nationally protected monuments reaching as many as 4,000 and 42 World Heritage Monuments at this stage. There are state archaeology departments across the country. Tamil Nadu, for example, has about 88, and if I'm not wrong, it's around 380 in Maharashtra. And these are not single structures, but in multiple structures in many cases. Apart from that, there are other departments which have very valuable historical structures. The state religious endowments departments is one such example. Waqf boards, another one. Public works departments across the country also have several thousands of historical monuments and heritage structures under their purview. We, of course, have many more under no formal institutional framework, and institutions such as NGOs such as INTAC or in Chennai, Reach Foundation, really work to address this big gap that exists in the domain of unprotected heritage. If you look at built heritage, they do present augmented vulnerability to natural disasters, and that's something that all of us are aware of. For me, I started my career, I think, as a master's student. My journey, I would say, not career, as a master's student in the first semester of 2001, and Bhuj earthquake had just happened. And it's one incident that really brings to fore the issue of vulnerability of to natural disasters in monuments. Kutch district with more than 15,000 heritage properties, it's recorded that about 2/3 of that was destroyed or extensively damaged. Well, the list doesn't stop there. You and I know that. We had the Indian Ocean tsunami in 2004, the Kashmir earthquake in 2005, Sikkim 2011, the Kedarnath floods in 2013, Kashmir floods in 14, Nepal earthquake in 15, Myanmar earthquake in 16, and the list goes on. And it's expected to go on. That's something we have to take cognizance of. We were talking about World Heritage Sites in the session this morning, and that's the earthquake hazard map of India. Seismic zones 2, 3, 4, and 5 mapped with the 42 sites that we have as World Heritage Sites in the country. The earthquake hazard map is in the process of being updated. It's going to change, and probably the picture will become even more stark. But the point is, 60 to 70% of our World Heritage Sites are sitting in moderate to high seismic zones. And therefore, that's something we have to take cognizance of. This is true for cyclones. This is true for coastal zones which are prone to inundation and other natural hazards and human-made hazards. In terms of statutory provisions, I think it's a room full of people who know the subject. I don't have to go too much into detail here. There are charters, international charters, which all of us are aware of. And as far as the nationally protected monuments, we have the MSR Act and its amendments, and the National Monuments Authority since 2011, which looks at aspects such as bylaws and permissions for changes in and around monuments. The National Conservation Policy, two important aspects that for built heritage conservation we have to keep in mind is it specifically requires, and not many documents internationally have ventured into doing that, which is it requires that monuments of national importance have to be scientifically assessed and retrofitted. And mind you, we are talking of 3,497 monuments. It's a huge number systematically if one were to address all this. Conservation efforts at all monuments, and those of you who have prepared conservation management plans are aware that disaster management plans also have to be prepared for each monument. That's a big ask for the number of monuments that we have in this country. State protected monuments typically follow a similar pattern, and you would have to look at each state has its MSR Act. Tamil Nadu in 71 had its Act, 66 and 71 had its Act. And then, of course, there are recent guideline documents, important guideline documents on disaster management. National Disaster Management Authority with the Home Ministry has come up with National Disaster Management Guidelines for Cultural Heritage Sites and Precincts in 2017, and another document for museums in 2017. So these are guideline documents for us to acts and guideline documents for us to act within. In terms of scientific assessment of risk in this country, there are lots of efforts, but I would think in our country, given that we are 75 years from the independence, the knowledge, our own knowledge on the structural behavior of our monuments, the massive monuments, is still something that is limited and needs efforts to fine-tune, refine, and have a greater understanding. There are a number of international and Indian researchers who have spent decades in documenting our monuments, but then the focus has mostly been on historical and architectural descriptions. One important aspect is how, for example, the documentation, as we all understand, of the Puri Jagannath Temple, Sri Jagannath Temple at Puri, we're not completely clear of the kind of structural details that actually exist. Structural details that actually exist in the triangular portion, while the Sthapatis would actually know how that can be constructed. Since that's a sealed off portion of the structure, we are not aware of what is the actual measurement within such a space. Now, if you don't know that, then it starts becoming difficult to design anything to support the structure. We start erring on the conservative side, and we'll say we'll make things heavier to temporarily or even permanently support such constructions. So that's That's limited knowledge on structural behavior and on the structure itself currently. If you look at the current status in our country, we still use traditional construction materials and practices in our country in the renovation of heritage structures. In many parts of the country, you have artisans, you have experts who still know how to prepare these materials and use them in the right manner. The picture on this side is actually related to the previous point, which is limited knowledge in the structural behavior. This is a very interesting document which talks about the domes of South India, and it is startling to see a 13th century dome in stone, which has, if you can see the drawing here, you can see a series of vertical along the horizon and meridional ribs. And that actually tells us that in the 11th and 12th and 13th century, there was an understanding of how a dome behaves, and that it is with the provision of meridional ties that you can actually ensure structural safety of this type of a construction. This, in the Renaissance period, was something that the Renaissance builders had to deal with in St. Peter's, Rome, and in late 1500s had to go and put chains around the St. Peter's dome. But you can actually see that something has actually gone into the original conceptualization of the structure itself. So there's so much that we still don't understand what our predecessors have actually done. Let me come to some sore points. Heritage safety education, and I focus particularly on heritage safety education. In our country, I would say there's still a lack of convergence, and this is because of our colonial past, modern day engineering education, and traditional knowledge systems. This is a truth. We are making small inroads, or we have forgotten a lot of things, but still there is lack of convergence. The undergraduate engineering and architecture curricula has almost no pedagogical content on ancient construction materials and methods of construction. The curriculum in civil engineering schools, we have progressively overlooked masonry and timber. Today, if you go to the curriculum in any of the civil engineering schools, it is not modern to actually talk of masonry and timber. It's okay because we're not using so much of masonry and timber in modern constructions. But the problem is we have such a large build stock of structures with masonry and timber that no engineer is now prepared to look at these from a fundamental perspective. The conservation curriculum in architecture schools is typically bereft of the structural safety angle. There may be exceptions. Expertise in safety-centric conservation engineering, and therefore, in our country, we don't have the critical mass. And that's, given the number of monuments we have, is a big challenge. Heritage safety practice, education versus practice now. There's limited infrastructure with state agencies, and this could be the reason for not undertaking R&D in subjects like structural safety of historical monuments. The conservation efforts in the private sector, there's a real need for better synergy between architects and engineers if this subject has to move forward in the right direction. And structural safety is not typically in focus. And quantitative approaches are seldom taken. Most interventions in heritage structures happen post-disaster. We don't do too much of retrofitting. At best, we do repairs. They are often unscientific, ad hoc, semi-engineered, or non-engineered. We don't invest in pre-disaster retrofit. Most often, it is post-disaster. It's disaster management that we are doing. We're not doing disaster preparedness. This requires comprehensive program, and you have to be at it for decades. The current efforts in capacity building in conservation engineering, there are isolated efforts of research, but academia is often told that you're not giving us implementable deliverables. You do all the research, but we're not able to implement what you're doing, research. So there's a disconnect between academic institutions and implementing agencies. When I say implementing agencies, I mean ASIs and departments of archaeology and other endowments department and so on. So moving forward, I would like to talk of a few things which then lead me to the core thrust areas. This is an important document, and Dr. Shika Jain, who's here, is one of the authors of this document, which was submitted to Niti Ayog, which is working group report on improving heritage management in India, and in 2019, and it sort of sets the vision for India's immovable heritage, and it's something that's a very broad document that gives a way forward for what our country should actually do. And the key word here is this is a development tool for socio-economic upliftment. And I think that all of us in this room recognize, but here is a Niti Ayog document that actually nails it. Moving on, so there's this sentence that I just wanted to read out, and with an all-encompassing, inclusive, multi-sectorial, multidisciplinary approach involving the entire gamut of heritage stakeholders is called for, from the myriad custodians and the range of heritage experts to the visitors as well as the citizens of India. This is a fantastic document. Please take time to read it because it does justice to India's concept of democracy, right? Moving on, I just wanted to talk a moment on the SDGs. All of us should be aware of the SDGs, Sustainable Development Goals of 2030, and where is cultural heritage sitting within this? It recognizes, the SDGs recognize, the documents recognize culture as a global public good and a critical enabler and driver of progress towards SDGs. In particular, and I'm not going too much into the details, it's SDG 11, Sustainable Cities and Communities, which require us to strengthen efforts to protect and safeguard world's cultural and natural heritage. And there are specific indicators that we need to take care of. Also increase the integrated policies to mitigate climate change and resilience in disasters. That again links with the Sendai framework, but talks of the role of both cultural and natural heritage. And there are indicators showing, are we making progress in this direction or not? So SDG 11 links directly to culture. Moving on, SDG 9, Industries, Innovation and Infrastructure, also require us to pay attention to culture, because instead of replacing a building which is functional with a new construction, it very specifically says that you have to try to rehabilitate the building, retrofit the building, and make value out of that building. And this, if there is heritage value to the building, you have no two ways about this sort of a situation. So target 9.4 actually talks about cutting down carbon dioxide emission by reducing demolition and rehabilitating buildings as much as possible. The Sendai Framework for Disaster Risk Reduction, again a document that all of us must be aware of. The DRR's Disaster Risk Reduction documents 2015-2030 also talk about the place that culture has, the cultural resilience of people has in the context of the assets, the cultural assets, the persons, communities, and in their countries. So this is, again, something that links to culture in the context of disaster risk reduction. And coming to structural engineering, there is one aspect that I mentioned the other day, and this is ISCARSA's International Scientific Committee on the Analysis and Restoration of Structures of Architectural Heritage. We have an NSC, ARSA, National Scientific Committee in ICOMOS, India as well, and they give recommendations for the analysis, conservation, and structural restoration of architectural heritage. And in the guideline document, this is where engineering comes into the picture. The guideline document actually says to provide, what ISCARSA does is to provide criteria and assistance for the study and interventions on heritage structures. These guidelines are based on the premise that a combination of both scientific and cultural insight, in addition to the necessary of all experts involved. In a place like Taprome, it's something like a botanist has to work with an archaeologist and a structural engineer to actually think of a solution to the site. Necessary knowledge of all experts involved is indispensable for the study and care of architectural heritage. And within such a multidisciplinary approach, yesterday we were talking about buildings having reached a limit of safety. Within that context, structural engineering can provide the scientific support necessary to obtain the expected result. And what is the expected result in built heritage conservation? Safeguard of the building as a whole with lowest possible consequences on the heritage values. And I think that's a guiding principle. And structural engineering can help you arrive at the right solution which has the least possible consequences on the heritage values. The guiding principles are being rewritten now and being revisited, and while doing that, there are new principles that are being talked about, you need to identify tangible and intangible character of the defining elements, adopt a minimal intervention. This has already been there. We need to avoid an overcautious approach to assessment. When we don't know much, we tend to say, increase the factor of safety. That is the problem which will actually lead to a very heavy intervention, which may not be warranted in a structure of historical importance. We need to improve and complement the structural behavior. We must not have methods where we completely short-circuit the structural behavior, but ensure that the structural behavior is improved. The existing structural behavior is enhanced and improved, is helped or facilitated rather than completely bypassed. We need to recognize the limitations of codes and conventional approaches. In the other way, we were talking about there are no codes in this domain. Why? Because these are not going to help you beyond an extent. We need to address criteria for structural interventions, compatibility with original materials and techniques, durability, non-invasiveness, removability after a period of time, controllability, you should be able to go and sustainability today. In the original guideline documents, we never talked of sustainability, but today we're talking of sustainability of interventions. Okay, so let me very briefly take you through these 6 thrust areas that I think are useful and essential over the next 5-6 minutes. Traditional knowledge systems and the role of modern engineering and architecture. The projects that I'm talking about are actually placeholders that we have, placeholder examples that we have actually worked on. This is an area that I think in India we must really work on much more. This is a project in a place called Tukkachi in Kumbakonam, a temple site that was not in worship for more than 60 years. That was the state of the entrance Gopuram, which after a process of multi-stakeholder involvement in September 2023, renovation efforts and restoration efforts and renovation efforts led to consecration of the temple. And this is a 12th century Chola temple in Tamil Nadu. This was taken up as a pilot project for structural conservation. And the key aspect here is the convergences and synergistic exercises that exist between modern engineering and architecture and traditional knowledge systems. And we were able to see a lot of overlaps possible in documentation, in diagnosis, safety assessment, and engineering method statements for execution that modern engineering and architecture can bring in. So this was a very interesting aspect if you work in religious sites, and which was what we were really looking at yesterday. So this was how the site was until 2020. What you're seeing is a drone survey, and the picture that you see here is on the day of the consecration on 3rd September 2023. A very successful project because it came together through the period of the pandemic and was executed rather rapidly and given back to the society after a period of over 60 years when there was no worship happening in this temple. The second aspect is a focus on digital tools. We are living in a digital era, and we do a lot of scan to BIM today. We do a lot of scanning, and we create models that we use for several purposes. Scanning to building information modeling for heritage structures is becoming a reality today, but we need to push it as engineers to another level, which is BIM to structural modeling. And we've been able to achieve that in one of the projects that we are involved in. So this is an ASI site, protected site in Ahmedabad, and we were looking at heritage impact assessment of the Jhulta Minar, if some of you must have heard of, in Ahmedabad, and the brick minars of Ahmedabad, and this was done for the railways. So we were looking at the impact of the redevelopment of the Ahmedabad railway station, where what you can see is scanned model is converted to a 3D model, and the 3D model is then imported to a structural analysis program, and the structural analysis program is able to do the necessary calculations to look at the impact of vibrations, the impact of excavations, and so on. So we were looking at if there is an excavation. This is a soil model with a monument model. If there's an excavation 80 meters away, what is the level of vibrations that we expect? And this sort of an information is what can inform heritage impact assessment and a decision on whether or not a redevelopment project can actually be allowed in the vicinity of a historical, a nationally important monument. So this was one interesting project that we had done. And in fact, the construction actually happens within the 100 meters, which is the no construction zone. But the point is to say no without an assessment, a quantitative assessment versus a blanket rule is something that is debatable. That's the whole point. A third aspect is about field and lab testing, because material and structural characterization is essential. And to support me was the answer that I had given in the morning session. This is the Rashtrapati Bhavan, the sunshades of the Rashtrapati Bhavan, which were very badly damaged due to deterioration of the lime concrete, and these are reinforced lime concrete sunshades. And over a period of about 4-5 years, we've actually worked with the CPWD and put in place a system of renovation of all the sunshades. These were originally, according to Lutyens' drawings, meant to be in sandstone with iron dowels holding them, but when finally executed in lime concrete with reinforcement sitting inside. And from day one, they've started corroding. In 80 years, it was disastrous. 1.5 kilometers of the sunshade were shooting stars in Rashtrapati Bhavan, which was very, very dangerous for the entire staff and the occupants of and visitors of the monument. This has now been completed in concrete, in cement concrete, but removing the lime concrete and reusing in as much as possible the reinforcement of the original construction. And these are, floral patterns had to be put in place and so on. So here, scientific investigations is really the basis for the approach to the conservation itself. And then finally, what we've also done is we've put in place a monitoring and control. We actually have a system of health monitoring that has been executed for the entire stretch, which will tell us if there is corrosion and at what rate is the corrosion progressing, so that interventions can be carried out to curtail corrosion effects. Fourth one is on structural health monitoring, this instrumentation for structural health monitoring. This is an area which we really have to work in. We need collaborations with electronics and electrical engineers and computer science engineers, because there's large data that will come in. And in many monuments where there is a challenge of being able to take a quick decision on what can be done, or it's a very sensitive location, it is best to monitor and take decisions based on the data that you have. And here I'm giving you the example of the health monitoring of one cracked beam in Sri Jagannath Puri temple in the Natya Mandap, which has been monitored for a period of 6 years now, 2018 onwards to 2023 end. And now decisions are being taken based on all the data we have on what should be the direction of intervention. And the data has really been useful to avoid a knee-jerk reaction in going and completely changing the character of an archaeological monument, which is a living religious site. So this is, thanks to ASI's involvement, we were able to put in place and do remote monitoring. I do this monitoring from my room in IIT. It's wireless, it's through a GSM data card, and I'm able to collate the data and look at the performance of a cracked beam to be able to help work with the ASI and then arrive at what should be the intervention itself. So long-term health monitoring, ensuring structural safety with the lowest possible consequences on the heritage value. So this is what Iskarsa was also echoing earlier. Health monitoring, again, in the context of developmental works. This is at Chennai. This is the Law College building. It is a grade 1 heritage structure. And 9 meters from this building, you have a 21-meter deep excavation for the metro. And that was only possible because this is a government building, and the Chennai Metro Rail Limited is a government organization. And so there was no question of going to the court or dispute about how close the metro is running to the heritage building. Because of that, there were structural damages of course, because of differential settlement, but there was constant monitoring, and let me tell you, there was monitoring for more than 7 years in this case, which after the completion of all the works, of course, there were some temporary measures that were put in place, such as a temporary support for the cracked arch and so on. But finally, after the works were all complete, there was a thorough restoration, structural restoration of the cracked structure, following which a complete load test was done, because this is a law college where students were going to be using the space, and there was, what you see here is sandbags which are being used to check for, do a load test. So here, scientific analysis, scientific investigations, monitoring, temporary stabilization, control, and structural restoration and load testing, they really breathe new life into the heritage structure, which actually underwent a structural damage and created a lot of furrow about whether it is safe or not. The last two aspects that I just want to touch upon is we need to do studies on how some of our traditional construction systems are resilient, or do they need retrofit interventions in the face of natural disasters. So since my training is in earthquake engineering, I have been looking at certain aspects like this, the Madras terrace constructions and their earthquake performance. Because replacing Madras terrace constructions with reinforced concrete floors is fashionable. But then can we retain the Madras terrace floors, and is it safe, is something that we've been studying quite seriously. And this is, so you need to do testing, you need to do full-scale testing, you might have to do some field tests or some lab tests. And this is, we had a PhD student at IIT Madras who looked at studying the Madras terrace construction, replicating it in a laboratory, doing some load tests, and then showing that an improvement is essential for ensuring earthquake safety for such constructions. And there is a certain retrofit system which is now in the patent office, has been sent to the patent office. So there is a lot of research that you can do in these areas, and there's a lot of innovation possible in these areas. So you need research towards understanding traditional construction systems for improved structural performance, but through minimalistic intervention. This final slide on the thrust areas is again related to earthquake resistance of historical constructions. And I'm very happy to put this slide here, because I can tell you I've been working on this for 18 years. And these things don't happen immediately. They need a lot of patience. And the last part was a 3-year Department of Science and Technology project that we got between 2018 and 2021. The work actually started in 2007. But what we did is to understand how safe are these mandapa constructions, stone mandapas that are just placed one on top of the other, members are placed one on top of the others, without any interlocking in most of peninsular India. If you go to Gujarat, if you go to Nepal, you will see these constructions have dowels, iron dowels, or ball and socket joints. But in South India, you don't have any earthquake-resistant features. But the point is, these structures are meant to last for 500 years, 1,000 years, and rare earthquakes can happen. So it was research interest to understand the earthquake resilience of these constructions. So we constructed, this is the shake table facility, an earthquake simulator at IIT Madras, which was funded by the Ministry of Education for the National Center for Safety of Heritage Structures to study the behavior of structural systems in historical monuments. One of you might have to just click that. So this is the test that we had conducted on a prototype built by a Sthapati on the shake table, and the test is underway. And very little was sufficient to bring the whole thing down because there is no interlocking. But then, for the level of earthquake hazard that is there in peninsular India, we have quantitatively demonstrated that these constructions are safe for the level of earthquakes that peninsular India can actually experience. So a quantitative approach, but along with a qualitative approach, is fundamental in fields like this, and R&D is essential. This is the last part of the thrust areas, which is adaptive reuse. You have to really look at it in a very broad sense. This is one project, one building which was slated for demolition, but had to, because of the goodwill of the owners, which is Young Men's India Association, and the Ministry of Culture through National Council for Science Museums is looking at converting this building, Gokhale Hall, into a museum of freedom movement in Chennai. So a lot of thrust on adaptive reuse is essential, particularly for listed and unprotected heritage. So let me close. I've taken 5 to 10 minutes more than I'm permitted. The way forward, I have to put on my hat as a professor here, and I think the way forward is, even though it is not the fastest way forward, is education and capacity building. And in that context, we need to invest in education and capacity building. For government agencies responsible for heritage conservation, I am not a big fan of outsourcing. In-house capacity development is vital, particularly for engineering cadres within such organizations. Wholesale outsourcing has limitations. It's possible to outsource parts of it, but it's important to have in-house competency so that you can engage with the agencies that you're outsourcing it to in a more critical manner, and you accept only things that really are essential for the organization. We need to focus on collaborative R&D between implementing agencies and educational research institutions. It'll bring a lot more meaning to the research that our institutions are doing, and it will be of a deliverable nature because of the collaborative nature of the research. And in this subject, the traditional knowledge systems research can actually foster innovation. For example, that Madras Terrace construction that we had studied, it gave us an idea of a certain way of retrofitting it, and we were able to submit it to the patent office. So that's a little bit of an innovation, but it comes because we did a deep dive into understanding the traditional system. But then an important aspect through collaboration is preparation of charters, preparation of manuals, and guideline documents. There's a vast job opportunity in the private sector, both in core and emerging areas, and some of the emerging areas are digital documentation. We have a fantastic example of an organization that does great work in digital documentation here in this room. Health monitoring, assessment and retrofit, heritage impact assessment. These are areas where the, private companies can really make money. Making money is not wrong, but there are the technical expertise in those directions. It's time for our country to have, in our own country, expertise in these areas. And finally, on education, at the undergraduate level, it is going to be very difficult in the existing curriculum to insist on having one subject on heritage conservation or to insist on heritage itself as a core subject within education, but we can embed it. Curriculum is already loaded and there's little room for new courses. Elective courses may not be the best option because for all of us sitting in this room, heritage is not an elective. Heritage is a core course. But you can't go and make heritage an elective in an undergraduate course and then expect everybody to think like you. So we need to sensitize by embedding this subject in multiple course content, because no board is going to allow you one course for heritage conservation. That won't happen. At postgraduate level, and this is something that is a workable model, and I'm very happy to say this in Bombay, in Mumbai, because it's my experience with the museum, Sir J.J. College of Architecture, and the Mumbai Metropolitan Region Heritage Conservation Society, which together ran a built heritage conservation course, a diploma course, 6 modules, each module over 1 week, over a year, which I think was a fantastic model between 2014 and 2019. That model has moved on, but I think I have learned from it. I was module coordinator for the structural conservation course, but what we are doing at IIT Madras is in this direction. At PG level, we are now developing a user-oriented program for implementing agencies. So we are tying up with agencies. We have an MOU with Archaeological Survey of India. We are developing a user-oriented program. The model is a 1-year PG diploma with 7 to 8 courses without a dissertation. This is a course-taught course. The thrust is safety-centric conservation engineering of historical constructions. And the mode of instruction, everybody is going hybrid. I think it has advantages, so it will be hybrid to cater to working professionals who are actually working in implementing agencies, and also for the geographical spread. Because to expect someone to come from the Northeast to Chennai just for one course is not fair, when someone from Bangalore can come in much faster. And this will also address the private job market through some additional seats, but primarily it will be run as a user-oriented program for the state and central implementing agencies. And this will be conducted by IIT Madras through our center. Now, I forgot this last slide, I'm sorry. So this is the list of courses that we are thinking of at this stage. A PG diploma course in structural safety of historical constructions. There'll be a course on guiding principles. There'll be, I don't want to call it conservation principles because it's moved beyond that today into SDGs, for example. So there are guiding principles, a course on guiding principles, a course on historical and traditional materials, a course on historical, structural and foundation systems, digital tools for scanning, BIM and structural modeling, lab and field testing for geotechnical, material and structural characterization, structural modeling and analysis and assessment, material and structural rehabilitation and retrofit, disaster risk reduction, and project management for built heritage conservation. I'm sorry for that last blunder there. It's not built heritage construction, it's built heritage conservation. Sorry about that, but thank you for your patience, and I hope to have some feedback on the directions that we would like to take. Thank you. Was not over.
Well, we do have time for some questions or discussions.
It's not on.
Well, we do have time for questions or discussions. So if anyone from the audience want to share their thoughts or ask any questions to Dr. Menon, please.
Good evening, Dr. Menon. Jason here.
Yes.
So, professor to professor, I teach at the Department of Ancient Indian History, Culture and Archaeology at St. Xavier's, Mumbai.
Yes.
Apparently, we also run a course in AIC, that is Ancient Indian Culture and Archaeology, having 2 papers on monuments, on antiquities and general conservation. You mentioned in your talk the need to bridge the gap between academia and industry. I realize that the industry focus is basically on in the architectural college in your institute as well, while we teach the traditional building systems. What would you recommend in this scenario as steps to bridging the gap? Because I can see a lot of wonderful work being done by, say, Tejas sir, by yourself, by the ASI. So how can we bridge this gap between the traditional departments, the classics departments like ours, who also teach interdisciplinary studies, and maybe we can collaborate to give a holistic approach to both of our set of students and to enrich the space of built heritage as well as heritage conservation?
That's a tough question. Because we tend to, how much ever we are interdisciplinary, we tend to work with blinkers on. So I think the biggest challenge for heritage conservation is bridging the divide between arts and humanities on one side and scientific engineering and science on the other side. And this is not something I'm saying, but this is something my supervisor called the 2 cultures in heritage conservation. And these 2 cultures in most situations don't talk to each other and are at loggerheads very often. But it's this sort of a program that I had on the last slide is more on the tangible aspect of built heritage conservation and the kind of dialogue between the arts, humanities, and science and engineering will actually be beneficial to the guiding principles course, right? Guiding principles course. The second place where I think it is important is to know how to do archival research, historical and archival research. How do you read resources? So there is room for collaboration. And I think the way that can happen, for example, and I'm thinking only of the course that we are planning, is to have multiple resource persons sit together and prepare the course. Not come and deliver the course alone, but sit together and prepare the course. Because if they come and deliver, it's just going to be their part and they go away. But in designing these courses, I think there is room and the platform for convergence of ideas between the two cultures. I would think we have to make an attempt. I don't have any other solutions at this stage. Thank you. Yes, please.
Yeah, thanks. So, as a conservation architect or archaeologist here, so I have a question about the archaeological remains and excavations that we carried out. What about the stabilization or retrofitting approach to these ruins, and basically to have a cover because now we see globally there is a trend of covering the whole archaeological site where the people can move around and have a look at it from a top view, so that because ruins you cannot relate if you're walking on the ground at the same level. You have to go certain elevation so that you can view the ruin from the top. So building something that close to the ruin, it's something I feel is a big challenge. Because you don't know what is the foundation and how it works. We undertake GPR surveys and things like that. But still, I have a lot of questions about how to handle the archaeological heritage.
It's a very specific problem.
Yeah.
And I think that sort of a problem is a demonstration that heritage conservation is very much in the domain of architectural design.
Agree.
It's not a specialization. It's not a
Yes.
specialization. So you,
Yes.
you need architects to think about a context like that, for which some background on the importance of the material, importance of what archaeologists would consider, historians would consider as valuable, is important. And this is, for me, it's a design challenge. Okay?
Agree.
And there can be a structural engineering solution to it, there can be an architectural solution to it, there can be a material solution to it, but that can happen.
Yeah, and yeah, so just a little more part on it. So we have like a 4-foot wall, which is an archaeological ruins, which is dug out from the ground. You don't know the stability of the wall.
Yeah.
So you need to understand the material and everything, and you have to understand that it was buried in the ground and it's just been opened up. Sometimes even the stabilization hampers the overall structural health of it, I feel. So do you have any technological solutions for it?
No, I mean, from my archaeologist friends, I have learned that keeping them buried is the best way of conserving them. So the structural engineers and architects can leave the table. I mean, that's the best solution. But
Sir has given the answer in a very lighter mode, but I would like to give answer for Archana's question. See, this concept of creating a shed over an excavated area or excavated site is very new, recent one in India itself. At least I believe I can count on finger 1 or 2 sites where the SI has tried this methodology to protect and showcase the buried structure to the visitors. One such is recently done at Adichanallur. Not Rakigadi. It is in Vadnagar by State Archaeology Gujarat and by Archaeological Survey of India. They are doing it now. And one it is Kalibanga. Only 3 places. Kalibanga, design-wise, is certain constraints, but Adichanallur has come up very nice. This is the initial stage, and it's up to you all, architect Adichanallur. It's an iconic site in Tamil Nadu. You all architects have a challenge now to give us a better solution and better design for such excavated remains. But as far as I understand the archaeological remains, there are hardly any places, hardly any sites where we can showcase in such a manner. Rakhi Gadi might come up. I don't know what is the situation. Tejas might be knowing it. But Kalibanga, there is hardly any scope. Whereas at Dholavira, again, hardly any scope. Abhijit is trying at Vadnagar. Let's see what comes up with his design and all. But it's a very initial stage, far way to go, and you architect has to give up a better solution to us how to showcase that excavated material.
The group of archaeologists.
We had sent a team from Directorate to Vadnagar in order to see what they have done, what could be avoided, and what can we actually achieve by having a better dialogue with conservation practitioners, archaeologists and administrators. So we might be attempting the same at the site of Tel in Usmanabad.
Yes.
Implementing, you said it will be for pan-India and you told...
A PG diploma course with enrollment primarily meant on a collaborative basis for implementing agencies, but also with seats which are open to the general public. So we are primarily looking at tying up with, there is ASI, there is state archaeology departments, there are PWDs, there is endowments departments, all of which have engineering cadre and architects who can benefit from this sort of a course. So primarily it's designed for people who are already within these organizations who can be deputed to do this course, but we also keep it open partly to the private sector, to the general public. So it's a 7 to 8 courses spread over a year in hybrid mode with examinations. So regular, IIT should be able to give a degree after that, a diploma after that. So that's the idea.
Thank you.
In today's context, with all the authorities, the professionals and the agencies, those are focusing currently now the built heritage, conservation and management of built heritage, right? But still, the indoor environmental quality of the heritage structure, there are certain issues and those are yet not addressed fully. So what is your perspective on this particular issue?
It's actually very, very multidisciplinary. In fact, we have faculty members at IIT Madras in our civil engineering department who focus on indoor air quality.
Right.
So
that is one of the parameter of indoor environmental quality.
Yes.
There are other parameters like thermal comfort is
Yes.
there, air quality is there, acoustical comfort is also there.
Exactly.
And
So
other
that really gets into design domain as well, partly of changing the indoor environment.
Right.
But it is an area, since here the focus has been more on material and structural aspects. This is something that we've not explicitly thought about.
Yeah. One of your slide into that, you was talking about the monitoring of the structures.
Yes.
We need IQ monitors in the recently conserved structures.
Yes.
So we can get the data from the indoor environment,
Yes.
like you rightly said, the air quality,
Yes.
the percentage
Humidity,
of
temperature.
O2, CO2,
Yes.
temperature, humidity. These are the important parameters of the indoor environment, and those are continuously affecting the heritage structures which are recently conserved.
Absolutely.
So this is what the area I think, sir, need to be addressed for the
Particularly with murals,
currently, yeah.
places with murals and.
Right, sir. Yeah.
Thank you.
So I just would like to know that you already mentioned the building health monitoring systems. So are these systems like sensor based, or what kind of technology is that you're talking about?
These are sensor based. Some of these are physical devices. Like if you have a crack meter, that's a physical device, but it can be electronic. You can have a tilt meter, which is again attached onto a wall, and then the tilt angle can be given. You can have settlement measurements. So there are a number of sensor-based instruments, and there are some others which are basically measuring some physical quantity. You can have static measurements, you can have dynamic measurements, particularly you want to check vibration levels due to traffic movement. You can put vibration sensors and cutoff values for alarms. So there's if you want to control the water table level at your site, you can have standing pipe piezometers which will tell you what is the level of. So there's a whole gamut of devices possible, but they need not be high-tech, wireless, expensive devices. They can also be simple mechanical devices, which is also adequate. Probably the simplest NDT is a pair of eyes, but the question of monitoring is so fundamental. Resources can then dictate how complicated and sophisticated they can become. Thank you.
I just wanted to ask you one question related to digital documentation. I mean, even at CEPT and at IIT Chennai, both the institutes are extensively exploring that whole aspect. And one major problem that we face is the issue of digital divide. While we as institutes, we do have access to all the equipment, the corresponding software and the storage infrastructure that is required. But one problem that we have faced is that even after generating that sort of data, accessibility to that data by other professionals and stakeholders is still kind of limited. So what are your views on, what kind of role ASI or state archaeology or other institutes can play to reduce this digital divide? Because very often, even if data is available, if it is not accessible, then it is as good as not having that data.
That's a very tough question. I mean, I don't think IIT Madras, we had the possibility, government had given us the money to buy a scanner, a laser scanner. And I did that in 2013. Looking back, I think I should have invested the money elsewhere. Because institutions like IITs receive money at one point in time, but we never get money for AMCs. We have to generate our own funds for AMCs, and then the rate at which, the pace at which these devices get upgraded is mind-boggling. In 6 months, your device is superseded. It becomes redundant. So I think we have the luxury of purchasing these, but then we are also not doing the best by purchasing these. But to answer your question, the most important thing to do is open source. And that will not work top-down, it will work bottom-up. We have to start putting our data out there with credits with the plea that please give credit to the work that is there. This is common good. Our ancient Vedas and all other things didn't come with copyright. All of us use that. What are we worrying so much about copyright? And this knowledge has come to us from somewhere. So if we take a bottom-up approach of putting data out there in a careful, in a systematic, unbiased manner, I think we can change the culture of accessibility to data. Today we are, I think, facing serious problems in terms of access to data. Thank you.